Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use TIA Portal version 17 to create the UDT and faceplate to control the PLC schematic S7-1500. Okay. If we would like to talk about the UDT, UDT stands for User Defined Data Type, that we can use the library. It means that the library we create only one, and then we can apply to another function. Yes. Example, we have 100 motors, then we use only one library, and then we can copy and paste to use to apply for all 100 motor. Yes, and we can control the motor one by one, follow the format that we created on the UDT. Okay. And in this section, I will detail about how to create the UDT and faceplate step by step and easy to understand. Yes, I will go slowly because it's very important for the basic create the UDT and faceplate. Okay, and I will use the schematic S7-1500 connect to my PC via LAN cable to Profinet port of PLC. Okay, and I will add some I/O for test to see the status. Okay, so let's go to our software to create the project and create the UDT and faceplate together step by step. So let's go. Okay, here is the TIA Portal version 17 that I already installed in my PC. So first let's create the folder to keep the file project. Example PLC S7-1500 UDT and faceplate. Okay, and then let's open the TIA Portal version 17. Yes, we will create the example project and create the faceplate to control the PLC. Yes, step by step. So wait a moment for open the TIA Portal software. Actually, we can create the faceplate by using the function step by step, but if we would like to use the UDT, it's faster than. Yes, so we can use the UDT. So right now let's create the new project, and then I will put S7 15,000 sorry 1500 UDT faceplate, and then I will browse to find the folder that we already created on desktop here, and then click create project. Okay, so take time a little bit more for create the project. After that we can create the hardware configuration of PLC. Okay, so let's go to project view. Yes. And then I will add the new device. Add new device of PLC S7-1500. Go to controllers. Go to schematic S7-1500. Go to CPU. And then I will use the CPU 1515. Yes, 2PN. And then I will choose the part number the same as my actual real hardware. And then click OK to create the project. So take time a little bit more to create the hardware configuration. Yes. After that, we can insert the I/O. Yes, insert some I/O. So here I'm no need the protection. If we would like to protect our project, we can also choose the setup to protect. Right now I will use the full control access. No need to protect. And then I will add some DI, yeah, digital input. Yes, digital input. And also digital output. Okay, and then we can go to hardware configuration to check the IP address of Profinet. Yes, full control. And for the Profinet port, we can check here 192.168.0.1 subnet mask default 255.255.255.0. Yes, and then we can save project. And now first we need to create the UDT, right? Data type. So let's go to PLC data type and double click to create the new data type. Example, I will rename this one to be fan UDT. And for fan UDT, I will insert the name. Yes. Example, stop CMD. Yes. Start CMD. Dry. Set speed. Or set frequency. Feedback frequency. Yes, and the data type here is real. Yes, example real. So I will put real. Yes, so we have one fan. We have stop command, start command, dry. It is the output to control the relay or contactor. And here is the set frequency. And one more example, current fan current. The data type is real also, because when fan running, it will show some current indicator to the HMI also. Okay, so we can compile the UDT, and then we can save the project. After that, we need to create the data block for keep or for apply the UDT. So let's go to program blocks, add new block, and let's go to data block. Yes, I will create data block name fan db. Yes, and then we can insert for fan 1 and choose the data type fan UDT that we already created here. So let's go to fan UDT. Actually, we can type fan, yes, fan UDT here, or we can select, yeah, here. Fan UDT, right? Yes, here. So we will got the parameter that we already assigned. So one fan we have totally 6 parameter. We have stop command, start command, drive. It is the output to control the relay or contactor. And we have set frequency, feedback frequency, and actual current. Okay. So if we would like to copy to fan number 2, number 3, and number 4 or something, we can right click and copy and paste, or we can drag like this. Yes, okay, like this. We will got the 7 fans. Yes, we will got the 7 fan. So if we would like to create the 100 fan, we can also drag to 100 fan. Yes. Okay, right now I will keep only 6 fan. Yes, so I can delete, and then we can compile and then save. So next step, we can create the function. Yes, so let's go to add new block and choose the function. Example fan fc. Yes. So here we can edit. Yes, we can write the logic. Example stop, start, drive, and then hold the start. And here we can use fan db. Yes, we can type fan db dot fan 1 dot stop, right? Dot stop cmd. Yes, and here we can type fan db dot fan 1 dot start db. So this start cmd. Okay, and here we can type fan db dot fan 1 dot dry. Okay, and here we can copy and paste. Yes, and for the set point speed and feedback, we can write the example logic. Yes, example, I will add real. I will add real. Yes, so add fan 1, set frequency, right? And example, I will add 2.5 and then equal fan dB dot fan 1 dot feedback frequency. Okay, and for the current of fan, we can use current of fan, we can use move. Current of fan we can use. Okay, I will add one more parameter for the UDT. So I will add current. So current show this one, current out fan current out, and this one fan current in. Yes, and then we will update. Yes, we will update the UDT. Update interface. Yes, and then let's compile again. Okay, so we will got fan current out, and then here we can move fan current in to fan current out. Yeah, so fan 1 current in, and then move to fan 1 current out. Okay, so we can compile the logic. Okay, there is no error occur, then we can save the project. And for fan number 2 to number 6, we can do the same procedure. Yes, so actually we can double click here and choose the fan 1, this one, example fan 1. I will rename to fan 1 FC, and this one I will insert one more for fan 2 FC, and we can stop, start, dry, hold the dry, and we have move, sorry, we have add, and then add the in one, right? In one, so fan2 fan db dot fan2 dot set frequency, right? Example, I will add 1.5, yes, dot fan2 dot frequency feedback, and here we can use fan2 fan db dot fan2 dot stop cmd, right? This one, fan db dot fan2 dot start cmd. This one, fan db dot fan db dot fan2 dot write, and we can copy and paste here. And this one, example, move, I will move fan db dot fan2 dot fan2 dot current in, and this one, fan db dot fan2 dot current out, yes. So this is just example, so I will create only 2 fan first, yes. So we can compile the logic. Okay, there is no error, so we can call this one fan 1 controller. So we can drag and drop the FC1 to the network. This one, fan 2 controller. Yes. Okay, we can compile. So for the logic we already created. So right now let's insert the HMI and then create the faceplate for these 2 fans. So let's go to add the new device, choose the HMI, choose the another HMI that we want. Right now I will use the TP700 Comfort version 17. Okay, so wait a moment for create the HMI edition. Okay, and then we can browse to find the PLC one here. We already created, and okay, no need this one, so we can click finish. Okay, we will got the root screen, yes. So I will delete some screen, yes. So we need to create the faceplate, right? For start and stop the fan, and also set point the frequency and show the feedback of current, yes. So let's go to screen. Here we can also rename the screen, example main screen. and let create the sample faceplate. So I will use the rectangle. Yes, and we have bone for start, right? And also for stop, so we can copy and paste. Okay, copy and paste. And then I will use the fan, right? So we can click here. Yes, click here. And then we can draw the fan. Yes. So here push button stop, right? So I will rename to stop and change the property to be red color for button stop. And here I will change to blue color. Okay. And then I will increase the size a little bit more to be 19. And here we can adjust. So actually we have a condition, right? So I will use the cycle for condition of fan. When fan running, it will green. When fan stop, it will red, right? So I will change the color to be red. And we also have the set frequency, right? Set frequency, then I will use the IO field. Yes. So I will adjust this one, and then we can copy for actual the frequency. Okay, like this. Then we can copy and paste. So this one feedback frequency, right? And copy one more. I will change this color to be this color. Yes. change to yellow color, and then I will decrease the size of fan little bit. Because we need to put the unit also, right? So this one should be current. Yes. So I will put the unit. This one should be hertz. And the feedback should be heard also. And for current should be M, right? So we can put the unit. M. Yes. And then we can try to adjust to be smaller than this because we have 6 fans, right? For this screen. Okay, so we can adjust. This one we can use like this. And then this one I will adjust to be smaller than this one. Okay. And then I will put the fan name, right? So here I will put name. And this one should be can adjust, right? So let's go to layout and then uncheck the fit object to content. Then we can adjust. And we can change the size. Yes. Okay. Okay, like this. And if we would like to create the faceplate, we can right click. Yes, first select all, right click and then choose create faceplate. Example fan faceplate. and we need to create the property, right? But before create the property, we can go back and then drag and drop the fan UDT. Yes, this one to be the project library first, because we need to use this data type, right? So we can drag and drop here. Okay, fan UDT, and then we can go back to the library. Yes, here, open library again, and then we need to create the property, right? So basically we can add property here, and example fan library. Yes, fan lift, and we need to choose the data type as fan UDT, right? Because all parameters we already created, so we need to choose fan UDT version 0.0.1. Yes, then we will got the parameters here of all fans. Okay, so we need to configure the button and status or IO field one by one. Yes, so first let's go to start and then go to events. Because we need to configure only one fan, and then we can copy to 6 fans. Yes, by using only one faceplate. So first let's go to freeze. I will accent it with set bit, and here we can browse to find the tag from property. So here I can use start CMD, and when release I will reset bit, go to property, and then choose start CMD also, because we need to push and release. It not allow the logic is whole, right? So we need to use freeze and release. And for push button stop, I will set bit and browse the property with stop CMD, and here reset bit, and then I will browse to find the property as stop CMD. Yes, and for the status of the fan, we can go to animation, go to display, add new animation, and choose the apparent, and then go to property fan drive, right, and choose the rank 1. I will change color to be green when the fan running. And also we have set point frequency, right? So set frequency, we can go to property general and choose the property data type that we already created. So here is the frequency set, right? Okay, so I will choose frequency set, and this one should be 99.99. Input output, that's okay. And for this one I will choose property also, and then choose frequency, yes, feedback frequency, and choose the output only, right? And for the format I will choose 99.99 also. And for this one I will choose current out. Yes, fan current out. And then I will choose output also. And for the format I will choose 999.9. Okay. And then for the M name we can also drag and drop to the property. So this one is text file, right? This one, yes. So we can go to the general and then drag and drop the file to be data type, sorry, to property. Okay, it will automatically link. And then we need to call, yes, we need to close the faceplate also, right? So I will add one more button for close the faceplate when we would like to close, yes. So we can go to toolbox again and then choose one more button for close the faceplate here, yes. So I will close. I will insert and change the font size a little bit. Go to text format and then we can increase. And then I will change to this color. Okay, like this. And then we need to create the one more property, right? I will add more property for visible the text, yes. So this one should be visible faceplate, and the data type is boolean, yes. So here we can reset the faceplate, right? Or we can use the property outside the faceplate, right? So I will delete this one first. We will do it later. Yes. We can also insert here. Okay, let's insert here. Visible faceplate. Okay. And then this one I will go to events. When click, I will reset the visible faceplate. Yes. And then we need to hidden the faceplate, right? So we can click all. And then go to animation, new animation, visible, right? And then we can visible the faceplate. Okay. Okay, good. So that's all for create the faceplate, and then we can release the version. And then don't forget check the update instant in the project. Okay, and we come back to our main screen. Okay, we will got like this. And then if we check on interface, we will got like this. Yes. The text is the name. Yes. So for the name, we can choose the fan one. Yes. It come to fan one. And for this one, we can choose the data type, HMI text, browse to find the DB. Yes. And choose the fan one. Yes, we can go here, DB, and then choose the fan one. And here is the visible. So we can create the internal text. So on HMI text, we can insert the internal text. Example fan 1 visible, fan 2 visible, the data type is boolean, and I will choose the internal text. So we can drag. We will got fan 3, fan 4, fan 5, and fan 6. Okay, then we will go back to main screen, and here we can choose the HMI tag, yes, and then choose the fan 1 visible. So if we try to simulation, yes, it will hidden all the faceplate, right? Okay, so we need to call the faceplate from the button, right? So I will use the one more fan. Yes, let's go to toolbox, and then this one. Okay, and then we can use button to call the fan 1 faceplate. Okay, and then we can go to property and choose the transparent. Yes, we will go like this, and then here we can use 0. Yes, like this, and then we can go to events, and when click I will set bit. Fan 1 visible, right, that we already created on the HMI tag internal. Yeah, here. Okay, and then let's test again. Okay, we will go like this, and when we click, the pop-up will update. Yes, and we can also close. Connection disconnect because we not yet download the logic to the PLC. Yes, so that's good, and we need to adjust some font a little bit. So let's go to edit the faceplate. We will adjust this one to smaller than this. Go to property, and then go to property again. Text format, I will change to 15. Yes, and then don't forget release the version, and the version will go to version 3. Okay, go to main screen again. We will got the faceplate like this, and one more thing, we need to change the color of the fan also, right? So we can go to toolbox, and then we can change the color of fan. So when the fan stop, I will show red, and when the fan run, I will show green. So go to animation, go to apparent, choose the take name, so go to data block, choose the dry, yes, and when the condition true, I will change the color to be green, border is green also, yes, like this. Okay, and for the fan number 2 to number 6, we can just copy and paste. Okay, that's good. So we can adjust this one a little bit more, yes, before we copy, so we can adjust. This one a little bit. Okay, like this enough. Okay, so save the project and then we can release the version, go to version 4, and let's go to main screen again. We can simulation again before copy to fan 2, fan 3, fan 4, fan 5 and fan 6. Okay, try to click again. Okay, that's good. I will decrease the font size a little bit. Go to property, go to property again, and then go to the text format. I will change to 13. Yes. This one should be, can adjust, right? Okay, like this. Save the project and release. Go to version 5. And then we can go to main screen again and let simulation again. Yes. Make sure the screen that we already created is good. Okay, we can read set frequency, feedback frequency and current of the fan. And then we can copy. We can select like this. And then we can copy and paste. We will got fan 2. Okay, I will put the one peg to fan, right? So there are 3. 3 peg, yes, put like this, easy to see and easy to control also, yes. So I will put like this, yes. Okay, and for the fan tool we can go to property and then go to interface, change this one to fan 2 and this one change to fan 2, or we can browse, yes. The data type is fan 2 and for this one is fan 2 visible, and just change this one to fan 2 dry, right? This one. Actually we can browse it, go to fan 2, go to dry, and this one go to events, change this one to 2. Okay, we will got like this. We can simulation. Okay, so if I click fan 1 or one button come here, right? So let me check again. This one here, and then we can copy to fan 3, 4, 5 and 6. So basically we can create the more screen. Example, this one is fan 2, fan 3 and fan 4. Yes. We can also copy from the main screen. Yes. So I will select this one, copy and paste. Yes. And paste one more. So this one should be fan 3, right? So go to interface, change this one to fan 3. Yes, become fan 3, and this one we can browse, go to program blocks, database, DB, fan 3, and this one should be fan 3 visible, and this one go to animation, apparent, change this one to fan 3, fan 3 dry, right? And this one also push button, go to events, change this one to fan 3, and for fan 4 we can go to property, go to interface, change this one to fan 4, and this one we can browse to find the data block fan 4. This one, go to animation, browse the data block of fan 4, go to dry, yes. And for the button to call the faceplate, we can go to property, events, change this one to fan 4, yes. And then we can copy and paste for fan 5 and 6, right? Okay, this one I will rename as fan 1 and fan 2, yes. And this one we can go to rename as fan 5, right? Browse to data block, fan 5, change this one to be fan 5, this one, apparent, change the text to be fan 5 dry, and call the faceplate, go to event, change this one to 5, and the last one, go to property, go to interface, fan number 6, right? Change this one to be fan 6, this one fan 6 visible, and this one go to apparent, and then go to program blocks, fan 6 dry, and this one go to events, change this one to 6, this one maybe I confused, so I will change. Let me check to make sure. This one should be fan 4, right? This one correct. And then we need to call the peg, right? So I will add the button to call. Example, go to main screen, and this one go to fan 1, fan 2 screen, this one go to fan 3 and fan 4 screen, yes. Can put like this. And for go to the main screen, we can go to events. When click, I will activate the screen, and then choose the screen name. The screen name is the fan 1, right? Oh, this one should be like this. Fan 1, fan 2 screen, and then this one go to events. So we can call the fan 4 and fan 5, right? Sorry, fan 3 and fan 4. Yes. So when click, I will activate the screen and then choose the screen name. So fan 3 and fan 4 here. Yes. So we can right click and copy and then go to fan 5, paste. So we can rename this one to fan this one 5 and 6, right? Fan 3 need to call fan 4, sorry, fan 5 and fan 6. So I will rename this one to fan 5 and fan 6. And let's go to fan 5 and fan 6, and then I will call fan 1 and fan 2 screen, and this one should be fan 3 and fan 4. That's correct. And copy to the main screen. We will call fan 2 and fan 3. Fan 4. Sorry, fan 5 and fan 6. This one, fan 3 and fan 4. Yes. So we can go to events and change this one to be fan 3 and fan 4, right? And this one we will change to fan 5 and fan 6. Okay. And then we can simulation the screen before download the program and then test with the PLC. So fan 1, fan 2, let's go to fan 3, fan 4, fan 5. Yes, and fan 6. Okay. So we can switch the screen. Follow we edit. Yes. Okay. So for the faceplate we already created. So next we will go to our logic, right? Okay, now before go to download the hardware configuration, I would like to revise some hardware configuration a little bit. Follow my hardware, actual hardware. Yes. So the first one is digital input. Yes. So 1BH00. Okay, I will check again. maybe I need to revise again, so I will delete the existing one first, and then I will go to the digital input module again. So 1B800 here, yes. So I will drag and drop to the rail again. And then one more is 1B801. It is the digital output, right? So let's go to digital output and then go to 1B8, right? One B801, yes. Okay, this one 1B801, and the last one is 1BL00. Okay, so I will add 3 cards also. Digital input 1BL00, yes. And I will connect the LAN cable from the Profinet of CPU to the LAN port of my PC. So let me check. Okay, I will connect the LAN cable. Okay, right now I already connected the LAN cable to the PLC, and then let's go to download the hardware configuration. Yes, before go download, I will save the project and then I will compile the project again. Okay, compile successful. There is no error, but have warning too. There is no problem. Yes, we can use, and then we can go download. Yeah, download one. So wait a moment for connecting, and then I will choose the correct Ethernet LAN connector. Yes, driver, and then choose try all interface and start search. It will detect the CPU. Yes. So right now it detects one PLC underscore 1 here. Yes, it is the name, and then we can click load to download. During load the hardware configuration, we need to stop the CPU. Yes. Okay. Continue without synchronization and click load. Stop the CPU. I will stop all. Right now the CPU was stopped. Okay, and I will choose start module. Yes, If I push start, I push finish, the CPU will running. Okay. Right now the CPU is running, and then we can online. Okay, and then we can go to the OB1 and FC1 to see the status. Yes. Okay, right now we can online, and then let's go to fan 1. Yeah, fan 1 screen, and then we can simulation. I will compile a little bit before simulation. Okay, there is no error, and then we can simulation. Okay, the connection was connected, and then we can go to see the status here. If I push the start, let's see here has the value. So if I set 25 Hertz, yeah, let's see here have 25 Hertz, and if I would like to start, I can start. Yes, it's running. I stop, it stop. And for the fan number 2, yes, we can also test. I will go to FC2 fan number 2, and we can online. Yes, and then I will set some parameter. Yeah, example, I set 50 Hertz or 20 Hertz. 20 Hertz. Yes, and here is the button start and stop. So if I push start, let's see, the output was running. I stop, start again. Yes, I start number 1. Yes. So for fan number 3 and number 4, we not yet create the logic, right? So we can create it. Okay, I will go offline first. And then we can go to the add new blocks. I will write fan 3 FC block, right? So fan 3 controller. Okay, and then I choose push button stop, push button start, and output. And then I will use nominal open to hold the signal. And then here we can type fan db dot fan 3, right? Sorry, dot fan. Okay, dot fan 3 dot stop cmd. This one, fan db dot fan 3 dot start cmd. And for the output, fan db dot fan 3 dot dry, and here we can copy and paste. Yes, and for the set point frequency, we can also use the example. I will use add, and here I will add fan dB dot fan 3 dot set, right? Example, I add 1.4, and then this one should be feedback, right? So fan dB dot fan 3 dot feedback frequency, right? Okay, and for this one we can use move fan dB dot fan 3 dot frequency in, right? So maybe I will use only 4 fan, sorry, only 3 fan, and then for another fan everyone will understand, okay, the same concept. So here fan dB dot fan 3 dot frequency out, okay, and then we can save. And if we would like to turn on the output of PLC, maybe we can use like this. Okay, I will call fan 3 first. Okay, and for the fan 1, command dry. Yes, I can use fan dB dot fan 1 dot dry, right? And then I will turn on the output of PLC. So let's go to hardware configuration. Here is the output module, right? So let's go to property and then check the address of the output. Here IO address, and then it will start from Q0.0, right? Okay, so we can go to main program, and then this one I will try fan 1 dry, and then we can define take output, right? So we start from Q0.0 define. Okay, and for fan number 2, here we can copy, change this one to fan number 2, and then we can use the NO. So fan dB dot fan 2 dot dry, right? And then I will turn on one more output. So fan 2 dry, and then we can define the take. Okay, sorry, output, it will start from Q0.1 because Q0.0 we already use. And for fan number 3 also the same. So I will use normal open. So fan dB dot fan 3 dot dry, turn on the output. And during testing, I will show the status of the PLC. It will work perfectly. So this one, fan 3, and then we can define text. Go to output, global output, yes. Okay. And then we can download, yes, compile and download. F33 has been not compiled, right? So I will go to FC3 first and then compile first. And then I will go to main again and compile again. Okay, there is no error. And then we can download. Okay, right now the output was turned on because we have command start from the HMI. Yes. Okay, I will show the status of PLC. Okay, so I will go to HMI. Yes. Let's see, right now the fan 1 and fan 2 was running, right? And then we can see the output was turned on. And if I start the, I stop the fan 1, yes, output turn off. Stop the fan 2, output also turn off. Start again, yes. And I will go to start the fan 3, yes. I will start the fan 3, yeah. The output turn on. And let's see here, it's turned on also, yes. So good. So if we would like to connect the digital output to use with the VFD or use with the relay or contactor, we can connect from the PLC, yes. And for the fan number 4, number 5, and number 6, I will monitor only DB, yes, data block. Let's see here, we can online to see, yes. And then we can open the faceplate, yes. So if I push start the fan 4, we need to create the program, right? So this one, let's see the signal was on and off, yes. And if I go to fan number 5, yes, I start, let's see here, is true, stop, also true. And fan number 6, okay, it worked. So maybe I will go to create all the program for fan number 4, fan number 5, and number 6 for easy to understand. Okay, so let's go with me together. Basically, we can copy like this. Copy and paste, and then we can rename, yes. This one should be fan number 4, yes. Change this one to fan 4. change all to fan 4. And then we can compile. Copy and paste more. Fan 5 FC. Okay, this one should be changed to fan 4. This one I will change to fan 5. Okay, this one fan 5 also. Let me check the fan 4 again. This one already changed, right? Okay. Okay. And then the last one we can copy and paste and rename to fan 6. Fan 6. Okay, and then we can compile the block and save. Go to fan 5 again and then compile also. And then we can call the fan this one I will call fan 3. Fan 4. Sorry, this one fan 4, fan 5, and the last one fan 6. Yes. And then this one we can also add more for fan 3. I will add normal open and then so this one fan db dot fan 3 dot dry, right? And then turn on the output fan 3 dry and then define text the output Q0.3. Yes, and this one for fan 5 also no coil fan db dot fan 5 dot dry and this one fan file dry, define text, and then go to global output and define automatically define for us. And the last one, it is fan 6, right? So no coil fan db dot fan 6 dot dry, and this one should be fan 6 dry, define text and choose the global output. Okay, and then we can compile the program. Okay, there is no error. Let's see here, it is F3 F3 F3, right? So when we download the logic, it will go to automatic FC456. Okay, so I will download again to reinitialize the block. Okay, let's see here, FC1, FC2, FC3, FC4, FC5, and FC6. Okay, that's good. So we can online. And we can monitor, yes. So right now all output was turned on, yes. And then I will go to the screen 1 again and go to simulation. Okay, so right now all fan was turned on, yes. Let's see the output turn on, 6 bits. Okay. And if we would like to stop, we can also stop. Yes. Okay. Fan 3. Okay. FC6, okay, good. We can online to monitor here also, yes. Okay, our fan was running. Yes. So this is just an example about how to create the program for control the fan by using the UDT and faceplate that create with the TIA Portal version 17. Okay. So thank you very much for watching my video. If everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use the WinCC Explorer version 7.5 connect with the PLC S7-300. That topic today we will discuss about how to use the analog input and output module of the PLC CPU 314C 2PN/DP. The concept of this video, I will show and share about how to use some analog signal connect with the SCADA WinCC Explorer. Example, we can set point the frequency of the motor to the VFD or to the some electrical devices, and we can show the feedback from the VFD or feedback of the motors frequency. We can show current of motor, or we can show the status of the temperature of the motor. Okay, so this include the analog input and output. Basically, if we would like to set the frequency of the motor to the VFD, so we will use the analog output, right? So example, I set 25 Hertz. So I will use the analog output connect from the PLC to the VFD. Okay. And if I would like to show the frequency of the motor or current of the motor or temperature of the motors, I will use the analog input connect from the sensor or VFD to the PLC module. Okay. And in this section, I will show and share about how to use the scale analog input and unscale analog output. And then we will connect to the WinCC Explorer. Okay. So in this section, I will use two software. The first one is Schematic Manager, and the second one is WinCC Explorer. Okay. So to do this job, we need to know about how to wiring the connection of the PLC, right? So the wiring is very important. If we don't know about how to wiring, we cannot do the project also. Okay. So I will show how to wiring. Okay, here is the library of my tool. So I don't have VFD or some sensor. So I have only a multimeter for measure the analog output, and I have RTD calibrator for send the temperature of the motor. Yeah, this one, just example. And I have the current loop source. Yes, I solve with the milliamp to the analog input to show the frequency of the motor and current of the motor. Okay. So here is just example about overall of the terminal of this module. So in this part we don't discuss because we already learned in the previous video. So we will discuss only this module. Yes. So if we purchase the CPU 314C 2PN/DP, we will got the 24 digital input, 24 bits, 16 bit of digital output, and we will got the 5 analog input 5 channel, and we will also got the analog output module 2 channel. Okay, so it built in this CPU. 314C 2PN/DP, and we have also profinet port 2 ports and profibus 1 port. Okay, so we will discuss about how to use the analog. So we focus about this module, this part. So here is the detailed drawing. So totally I have connected of my RTD calibrator, current source loop, and multimeter connect to the terminal. Follow this step. So if we would like to use the RTD, we can use the terminal number 14 and 15. Yes, here. And this one is the analog input channel number 1, analog input channel number 2, analog input channel number 3, analog output channel analog input channel number 4, and the last one of analog input channel number 5 is RTD. So here on the hardware configuration, we will learn about how to configure for current or volt. Yes, so we can select among these terminal. If we would like to use current, we can use the terminal number 4, it is minus, connect with the terminal number 3, it is current. Example 4 to 20 milliamp or 0 to 20 milliamp. And if we would like to use volt, example 0 to 10 volt DC, we can use terminal number 4 with terminal number 2. Okay. So for channel number 2, number 3, and number 4, it is the same concept, except channel number 5, it is RTD only, so we cannot select volt or M. Yes. And for analog output, we have totally 2 channels. The first one is PQW800. If we select and connect the terminal 20 with the terminal 17, we will got M from the analog output. Example, we set point the frequency. So if the VFD or some electrical devices use current or volt, we can set from here, and then we can connect from this terminal to the device. Okay. So if we would like to use volt output, we can use terminal number 20 and terminal number 16. Okay. And for channel number 2, PQW802, also the same. Okay. So I hope everyone will got this drawing. Yes, because I already detailed. So it's very important for the wiring. Yes, that's why I just draft the drawing to explain to everyone. Okay, good. So now let's go to our software, WinCC Explorer and Schematic Manager, and I will detail about how to select the configuration volt M of analog input and output. Okay, so let's go. Okay, so right now I will use two software. The first one is Schematic Manager and the second one is WinCC Explorer. Okay, right now I use 5.6, version 5.6 of Schematic Manager, and I will create a new folder. WinCC Explorer connect with PLC S7-300. Okay, and we focus about how to use the analog input and output only. Okay, And then we can go to our software schematic manager and then create a new project. Yes, can choose file, new, and then we can put the project name, example WinCC Explorer analog. Okay, and then we can browse to find the folder that we already created on desktop. Yes, I will choose the folder here. So first we need to create the hardware configuration. Yeah, the same as my slide that I already show here. Yes, so we need to choose the CPU 314C 2PN/DP. Yes, okay, so we will create the schematic 300 station. Example analog signal. Double click again, go to the hardware configuration. Yes, so here we can use insert the rack. Yes, drag and drop the rack 300 to the project. Yes, and then we can go to CPU 300 and then find the CPU 314C 2PN/DP. Okay, here, and this is a part number, and here we can select the last version 3.3. Yeah, drag and drop the version 3.3 to the rail, and then we will got this one. Yes, IP address 192.168.0.1. okay, so please remember this IP address because we need to use with the WinCC Explorer. Okay, I will show in the next step. So let's click OK first. We will got here, we will got DI, yeah, digital input 24 bits, digital output 16 bits, analog input 5 channel, and analog output 2 channels. Okay, so now we will go to configuration of the analog input and output, right? Because we focus our topic. Yes, so to configure the analog input and output, let's go to double click and go to input. Yes, and here is the address. It will start from PIW 800 until PIW 809, right? The same as my slide that I already show here. Yes, it will start from PIW 800 until PIW 809. Okay, and for analog output also start from PQW 800 until PQW 803. Okay, totally 2 channels. So we will go to input tabs, and then here, let's see here, it is the degree Celsius. Yeah, because it related with the standard. Yes, resistance or standard RTD here. It is channel number 5, right? Here. So I will select with the input type the current because I have only current source and RTD, right? And here also I will use the analog output for current also, 4 to 20 milliamp. Yes, so I will select current. Yes, the default is volt, so if we would like to use volt, we can select here to use volt 0 to 10 volt or plus minus 10 volt. Okay, so it depends on our electrical devices. If input is volt, we can select volt. If input current, we can select amp. Okay, so right now I will select current, and then I will use standard. Yes, I will use 4 to 20 milliamp. Yes. Okay, channel number 2, I will select the same. It's very important for hardware configuration. Yes, for the basic. If we config incorrect, we cannot use with our device. Okay, so I will go slowly for easy to understand. Yes, so here also, and here I will use RTD 2L standard. Yeah, standard PT100. Yes, because I already connect here. Yeah, this one RTD calibrator for test, and here terminal 14 and 15. Yes. Okay, for analog output, I also use current. Okay. Okay, and then save and compile the project. And then we need to download. Yes. So please remember here, it will start from 800. Yes. And we can also edit. Yeah, edit the symbol. Example PIW 100. It is the current of the motor or something. We can also remark. Yes, so right click and then choose the edit symbol. Let's see here, we can write the symbol. Example the bit number 1, sorry, the channel number 1 address 800 PIW 800. So I will remark as feedback or frequency feedback, frequency or feedback speed motor. Yeah, I will use speed motor, and the data is integer, and we can command as speed feedback of speed motor. Yes, and for channel number 2 example, I will use feedback current of motor, right? Feedback current motor, and the data type is integer also. Yes, feedback current motor from VFD. Okay, on from VFD. Okay, and for channel number 2, sorry, channel number 4, number 5, channel number 3, number 4, I will spare. Yes, so I'm no need to remark something, or we can remark as spare, spare integer, spare channel, integer also. And we can remark here no use. And for PIW 808, right? So I will use the temperature motor, and here is the integer also, yes. And here we can remark as measure temperature of motor, yes. And here we have set point frequency or set point speed to VFD, right? So I will use set value speed motor, okay. And the data is integer also. This one should be word, right? So word. So set point speed to VFD, speed motor to VFD, yes. And this one I will remark as spare, yes. AQ spare. The data is word also, and I will remark as no use, okay. And then we can apply, yes, and save, compile again. And we need to download the hardware configuration to the PLC, right? So here I will connect the LAN cable from the PLC to my PC. Yes, so let's go to network adapter. Okay, this one not yet connect, right? So I will connect the LAN cable from PLC to the PC. Okay. So wait a moment for connect. So right now it connected, yes. Okay. Basically we can put the manual of IP address of our computer, yes. Because here is the IP address of PLC 192.168.0.1. So example, I can select 192.168.0. something, but not .1. Example dot 253, yes. Yes. And then we can download the hardware configuration. To download the hardware configuration, let's click here and then click download to module. Click OK and wait a moment for scanning the module. It will detect, yes, automatically detect the CPU if the LAN cable was connected from our PC to the PLC, yes, the Profinet port. So wait a moment. Okay, so right now it detects one CPU of PLC 192.168.0.1, and then we can click OK. OK again to confirm. During this time, it will stop the CPU. Yes. So click OK to confirm and stop the CPU, and then restart the CPU again. Yes. Finish download it. Save again to confirm. Yes. And then now we need to use the scale, right? If we would like to show like this, yes, we need to use the scale. Example, current of motor or speed of motor, yes. So let's go here, go to blocks, and then go to OB1, open OB1, and I will use the ladder. Okay. So the first one, we need to show the feedback speed of motor, right? Okay, so let's go to remark here. I will go slowly because we need to use the library. Yes, if we install the schematic manager, we will got the library. Yes, automatically got the library. Yes. So here is the feedback speed of motor, right? Example, rank from 0 to 100 and 1500 RPM. Yes. So let's go to library tab here. Okay. And then go to the standard library, yeah, to scale, because we need to scale the raw value from here. Example, if we online, yes, I will online. And then if we type PIW 800, PIW 802, PIW 804, PIW 806, PIW 808. Yes, and then we go online here, we will got the raw value right here. So this one I connected the current loop, yes, to this terminal. Yes, current loop to this terminal. So right now I will got the raw value, right? Because I series, yes, because I have only one current loop calibrator, yes. So I can series the signal, yes. So that's why this value is the same, yes. And for channel number 3 and number 4 is pair, yes. So there is no data, yes. The terminal is pair. And for temperature sensor, right now I push the clip to 50 degrees Celsius. So it error a little bit around 53, yes, degrees Celsius. And I will go step by step and explain about how to calculate to the actual temperature here, yes. So there are 3 types in this section. The first one is convert from raw value to the actual current or actual feedback of speed motor. And the second one is how to calculate the actual sensor. If we use the terminal number 14 and 15, so we have calculate not the same this one, okay. And one more, we have PQW 800, right? So this one is analog output, so we will use UNSCALE, yes, to set point the analog output also, okay. And then I will measure the current. If we control from the WinCC Explorer, so we can measure the current. If milliamp is vary, then the VFD or some electrical devices is vary also, okay. Good. So right now I will use scale, convert from speed feedback motor to the actual. Yes. So here go to the library tab and then go to standard library and then go to TIA event converting blocks and go down. Yes, go down to find the FC105 right here. FC105, it is convert from raw value to the actual. Okay, so drag and drop to the network and then we will got here FC105, it is scale values. So we can push F1 to see the hell. Yes, if we would like to see the formula, yeah, we can see here and we can read about how to use this function FC105. Okay, so everyone can read. Yes, from here what is the meaning of the en, what is the meaning of in, what is the meaning of hi underscore im. Yes, so it very informative here. Yes. Okay, so for the in here we can read. Yes, read together. So in, it is the input. Yes, input value to be scaled to read the value in the engineering unit. Okay, so it is the raw value from the analog input. So we can put okay, the feedback, right, PIW 800. So here we can put PIW 800. Okay, command will automatically, because we already remark on the symbol. Yes, we can remark from here. Yes, so it will show here and here is the high limit, right? So we can continue read. It is the upper limit in engineering unit. Okay, so it is the input also. And then here is the high limit. So example, the motor is 2 poles. Yeah, so we can select with the same as the nameplate of the motor. Example 1500 rpm. So I can use here 1500.0 rpm. And for lower limit here, lower limit in engineering, so I will start from 0. So 0.0. And here is the bipolar, it is the input also. So at the signal state of 1 indicate that the input value is bipolar. Okay, so default I will use the global variable. Yeah, example m 0.0. Yes, and next go to ret underscore val. Yeah, so continue to read here. So it is the return value of word, right? If the instruction executes without error, see error information for values other than word. Okay, so here is the word. So I can put any memory, example MW 50. Yes, and out, the last one is out. So out is the result of the scale, right? So we would like to know this actual value. So example, I will put, it is the real, right? So I will put MD 100. Yes, MD 100. So good. Now we done for the feedback speed of the motor. Yes. And then next we will create the current of motor, right? So we can insert one more network. So actual current of motors. Okay, then we can go to FC105 again. Yes. So no need to override. So we can click no. And for the symbol of the current, right? The symbol of the current is PIW802. Yes. So here we can put PIW802. Yes. So feedback current of the motor and high current of the motor, example 250 dot current. Yes, 250 m and start from 0.0 m, and here I can use m 0.1 and MW52, and here I can use MD 104. Yes, and then we need to show the temperature, right? Temperature transmitter. Yes, we need to show the temperature of the motor. Example, we install the sensor on the bearing or the winding of the motor, so we need to show the status of the motor, how much degree Celsius. So we can use network number 3. It is show actual temperature of motor. And then here we cannot use the scale, right? We can use the formula. Yeah. First we need to convert from integer to double integer. Yes. Actually, the previous video I already explained this one for PLC S7-300 Smart. Yes. But now I explain again. Yes. So first we need to convert from integer to double integer value, because this one is integer. Yes. So I will use the block convert from integer to double integer here. Yes. And then I will convert PIW, yes, 808 here. So we can also copy and then paste here. It is the temperature of motor, right? And then here we can use the temporary variable. Yes. Example, I will use temp1, and the data type is double integer, right? Because we use double integer. Yes. So we can select double integer here. So here we can select temp1. Yes. And then we need convert from double integer to real, right? So go here. Convert from DI to real, right? DI to I. Here. So here we can use temp1, and here we need to insert one more temp, right? So example temp2, and the data type is real, so I will select real. Yes, and here we can use temp2, and then I need to divide this one by 10, right? Because it is the formula. Yes, so we need to follow the formula. So I will go to divide real, so divide real here. I will divide temp2 by 10.0, and then I will got the actual temperature from the sensor. Okay, so example this one I will use MD 100H. Yes, and not yet ready. We have one more for set point value to the VFD, right? Example, if we would like to set the speed of the motor, we can set from 0 to 50 hertz, right? And then we can go to insert one more network. This one, set point frequency of motor to VFD, right? And here we can use UNSCALE convert. Yes, so drag and drop the UNSCALE convert to the network. Yes, and then here we can read. Yes, by push F1 we can read the formula. Here is the formula. Yes, and here is some value. Yeah, the standard value of this formula, and we can read. Yes, and here is the example of the scale block, yeah, function. So here is the enable. If we don't enable the block not work, right? Doesn't work. And here is the real. Let's see, MD 10, MD 20, MD 30. Yeah, it's just example. Because here is the boolean. Yes, here is the real. So real we can set from 0 to 50 hertz. Yes, of the frequency of the motor. So let's go to our network. So here I can use some memory that set point from the WinCC Explorer, right? So basically I can use MD 108 plus 4 112, right? Okay, 112. And here is the high limit. So high limit example 50.0. Yeah, it means that 50 hertz. Start from 0.0 hertz. And this one example I will use M0.2. Yes, and we can read here output is integer, and the return value, it is the word, right? So return value I can use MW54, and for the output is the result, right? The result is integer. So integer I can use some temp, right? Because we cannot put directly from this one to the PQW, right? Example, we put PQW 800, we will got error, right? Okay, so we need to convert. So it is integer, right? Here, integer. So basically we can use temp3 and data type is integer. So example temp3, and then I will move temp3 to PQW 800, right? So I will use move function and then move temp3 to PQW 800. Okay, so that's all. We have 4 items that we need to do. The first one is set value of frequency of the motor. The second one is show the feedback speed or feedback frequency. The third one is show the current of the motor, and the fourth is show the temperature of the motor. Okay, so that's all. And then we can save the project, and then we can go outside, and then we can download. Yes, go to block. Let's see here, if we put the FC 105 and 106, we will got the block generate automatically, right? And then we can select all and then download again to the CPU, select all, stop the CPU, and then restart the CPU again. Yes, and if we open to see the status here, yeah, we can online to see the status. So right now the feedback of speed motor around 373 RPM. Yes, so if I adjust the current loop, yes, adjust the current loop here. Yes, okay, let's see, the motor is 747. Yes, I select to 12 milliamp. If I select to 16 milliamp, yes, around 1124 RPM. If I select to 20 milliamp, it will show around 1498. It's nearly 1500, right? So it error a little bit. Yes, and this one show around nearly 250 M. Yes, for current motor. And for this one, we can select the RTD calibrator. Yes, right now I select to 0. Yes, if I increase, yes, right now I increase to 100 degrees Celsius. Yes, so it error 1.4 degrees Celsius. And for analog output, yes, I will show in the WinCC because we can set from the WinCC Explorer. Okay, so good. And then for the scale and unscale, we already created. So here we can remark as rank from 0 to 250 m, and this one so the temperature example, this one unlimited, right? But we have specific also, example 0 to 150 degrees Celsius. Yes, and then set value or set point to the VFD. So we can set from 0 to 50 Hertz. Yes. Okay. So I will decrease to the minimum. Yes. 0 RPM. Yes. And then now let's go to create the WinCC Explorer to do the peg for set point and feedback right here. It is just example. So let's go to WinCC Explorer, open. And then create the new project. Yes. Go to file and then choose new. I will insert the create the single user project only for test. So example connect with PLC S7-300 and browse to find the folder that we already created on desktop. Here, create. Yes. So wait a moment for creating the project of WinCC Explorer. And first we need to create the connection, right? From the WinCC Explorer to the PLC. So basically, let's go to Take Management, right click and then open. We need to insert, right, the connection. So right click on Take Management, go to Add New Driver and choose the Semantic S7 protocol suite, right? If we have Semantic S7-1200 or 1500, we can choose here. So right now I will use S7-300. So I will use the top one. Yes. Semantic S7 protocol suite. And then I will use the TCP IP, right? Because I connect with the Profinet port here, 192.168.0.1. Yes. Then right click and then choose the new connection. Example PLC S7-300. Yes. And then we need to put the parameter, right? Connection parameter. So right click, connection parameter. So here is the IP address of the PLC and here is the rack number of the PLC that we would like to connect from the WinCC Explorer. So here is the slot number. Yes. So let's check here, hardware configuration. So the first one is IP address, right? So 192.168.0.1. So I will put here 192.168.0.1. Rack number is the rack number 0. Yes, it is correct. Slot number, it is slot number 2, right? CPU is slot number 2. It is slot number 1 and this is slot number 2. So the CPU is 10 slot number 2. So I will put slot number 2. Yes, that's all. And then we need to set the parameter here also. So right click here and then system parameter, go to the unit. Yeah, here is very important. Yes, so I will explain. So if we would like to use the simulation, we can use PLC sim TCP/IP. Yes, .1. It is the protocol. But right now I will use the LAN cable, right? So LAN cable is my LAN cable here. Okay, we need to go slowly because otherwise everyone don't understand about how to do, right? So the connection that I connected to the PLC with my PC is Intel 82574L, right? So here we need to choose the network. Yes, current network that we connect to. Yeah, here. So if we would like to use simulation, we can use here. If we would like to use the device, connect directly to the device, example the PLC S7-300, we can select here. Okay, good. So like this, if we would like to activate the project to see the connection, yes, I will show. We can go to activate. Yes, and then the connection will show connect. Yes. So we will go step by step for easy to understand. Let's see here. It shows the trick signal. It means that the configuration of the project of WinCC with the PLC device is okay. Yes, connection status is okay. Okay, so I will deactivate first. So next we will go to create the text, right? Because we have 4 text that we need to use. The first one is feedback speed of the motor, MD100, right? So I will write as speed motor. So it is the real, right? So floating point 32 bits, it is the real. And the address is MD100, right? And next we need to show the actual current of motor, right? So MD104. So actual current motors. So it is real also. And the address is MD104. And next we will show the actual temperature of motor, right? So MD108. So motor temperature, the same data type, MD100H, and the last one is set point frequency or set point speed of the motor, right? So MD112, so set speed motor (112), MD112. Yes, so that's all for this text. And then we need to create the screen, right, to control or to show the actual value of the speed motor, current motor, and temperature of the motor, right? So let's go to WinCC and go to Graphic Designer, right click, choose the new picture, yes, and then I will rename this one to be screen 1 or motor screen, yes. And first we need to set the start up with this screen, right? So let's go to computer, go to property, yes, right click, property, go to property again, go to graphic runtime, and start picture. We can browse to find the picture here, motor screen, and here is the window attributes. So I will use screw bar, status bar, adapt picture. No need to use the full screen. Yes, if everyone would like to use the full screen, we can check box here. Okay again, and then go to our graphic designer and then open the screen to design the page for see the data or set point the value to the VFD. Okay, so wait a moment for open the screen. Yes, we use only one screen. For example, if we would like to use another screen, everyone can add more. Yes, because in the previous video I already show and share about how to create some screen. Yes, okay, good. So basically, if we would like to change color, example, I would like to change some color, I cannot change, right? So we need to go to effect and then global color, set to no. We will can change the color. Yes. Example, I will use some color here. It is my background. And then I will use the rectangle for show the current, set point or speed the motor. And here we can adjust the geometry to be 500 or 800, and the height is 600 or 500. Okay, we will got like this, so no need to use this one. Yes, 450. Yes, like this. So we will got the small page like this. So here I can use some symbol, so go to this tab and then Siemens HMI symbol library. Yes. Okay, and then we can zoom the picture. Yes, we can zoom the picture like this. And then if we would like to change the picture, we can double click and choose some picture that we would like to change. Example, we change to be another picture. Example, another motor here. Yeah, we can change this motor. Yes. And we have some parameter of the motor, right? So I will use the smart object here. Example, we use IO field. Okay, I will put like this. We can adjust later. Yes. So if we select the IO field, we will got the text, right? So this one I will use set speed motor. Yes. And choose the upon change. And here is the font size that we would like to change. Example, I change to 34 for size. And font, we can choose another font that we want. Example, Tacoma. And for the color, if we would like to use this color, we can also change. Yes. But don't forget, go to effects and then choose this one to be no. This one no also. We can change the color. Okay. So example, the background, change to black color for the background. So we can double click and then change to black. Yes. So I will put like this. Okay, and for this one is set value, right? So let's go to the static text. This one should be set value, right? So set value, set speed motor. So for the font size, we can change. Effect, we can choose no. And we can go to align the text. Example, central. So maybe I will add more for geometry to be 1000. Yes. So we have set speed motor. This one we can go to style, alignment X, I will go to left, and the unit is hertz, right? So we can put the unit. For the graphic, we can design the style that we want. Yeah, and for this one, I just for example, so we can put like the first. We can design to be better than this. Yes, and then we can duplicate. Select all, duplicate for feedback speed of the motor, right? So here PV, process variable speed of the motor. So the unit is RPM, right? So here I will go to center. Yes. And one more is show the temperature of the motor, right? So temperature we can duplicate. Okay, we can duplicate like this. So temperature, motor temperature. Yes. Temperature. Okay, so this one is degree Celsius. Yes, degree Celsius. And one more for show the current of the motor, right? So we can duplicate for current of the motor. So current motor, and here is M, right? So M. Okay, and we need to start and stop the motor also, right? I will create some logic for example. So I will add button start. Okay, go to effects, change this one to no. Okay, start, and one more button for stop. Okay, like this. And then this one we can adjust a little bit like this. And then this one should be blue. This one should be red, and then I have one rectangle to show the status of the motor, and we will add the logic. Yes, so don't forget, go to effect, no, change to red. Yeah, the status normal, motor stop, it will show red. This one we can adjust to be go to font 40, maybe. Okay, yes, and we need to choose this tag, right? Because we just put only one for set speed. For feedback speed, we can go to configuration dialog and choose the tag for PV speed of the motor, right? So speed motor here. Okay, and this one also motor temperature, right? So choose the correct tag with motor temperature, and for this one is motor current, right? So motor current. Okay, so that's all, and then I will create example logic, yes, to start and stop the motor. So we can go to OB1. Okay, I will outline first, just example. So start and stop motor command. Yes, basically we have stop, start, and output, right? So here I will use output. So let's check the output address, digital output. Sorry, this one unlock. Oh, sorry, this digital, right? So address will start from Q136.0. Okay, so Q136.0, it is motor 1 drive, and I have M10.0, M10.1, and hold signal by Q136.0. So this one example stop motor 1, this one start motor 1. Yes, and then we can save, download, can online. Yes, and we can go to the text management. Yes, so start stop M1, start M1, motor 1, and it is the binary text, right? And start from M0, M10.0, M10.1, Q136.0, right? Okay, good. And then we can go to our WinCC screen. Yes, So the start button, we can go to the events, go to mouse, and if I press, I will set to 1, yes, of the take start, right? And if I release, I will set to 0 and take start, right? It is basically because I already show and share in the previous video. The stop also go to events, mouse, and then go to direct connection. I will set to 1 when I press, and when I delete first this one, please. I will set to 1 with the take stop motor 1, and I will reset to 0 when I release. And then I need to show the status of the motor when running, right? I will change color to be blue. So go to property, go to color, and then go to background, go to dynamic dialog, and then choose the take motor 1, and choose boolean. And then when true, I will change to green. I will change this one to upon change, yes, to green immediately. And then we can save the screen. So that's all. And then we can simulation, yes, don't forget save. And then we can go to WinCC and then activate the project. And then I will show the status of the PLC also, yes. Okay, let's see here. It is just example for the screen. We can design to be better than me, yes. So example, I start the motor, yes. The output is turned on also for the motor, for the PLC, yes. I stop, I start, yes. And we need to see the current and speed, right, of the motor. So the first one, we can set point the speed, yes. I will show the multimeter when we set point the speed. Let's see right now the speed set point to VFD is 4 milliamp, right? So example, I will set to 50 hertz. We will got 20 milliamp, right? Example 25 hertz. We will got 12 milliamp, yes. And the speed of the motor PV, I will parallel with the current loop, right? So I will adjust. let's see, 20 milliamp, yes. So it will show around 1499, nearly 1500, right? And we adjust to 12 milliamp, it will show around 748, yes. And the temperature show around 28, and we adjust the RTD calibrator, yes, 50 degrees Celsius, 100 degrees Celsius, yes. So it shows perfectly. And here the start button, if I stop, yeah, the output is stop. If I start again, the output is start, stop again, yes. So it works perfectly, yes. So this is just an example about how to link the WinCC Explorer SCADA to the PLC S7-300, yes, by using the step 7 microwin schematic manager, yes, to create the example project, and WinCC Explorer, okay. So for the skin, everyone can design better than me, yes. I just example, if we got the value like this, we can design the style. It is pre-style, follow the everyone design, okay. So for this video, I would like to conclude, yes. I think everyone can do it because we use the library of schematic manager, yes. If we install the software, we can got this library, and then we can drag and drop to you, follow the instruction by press F1, and then we can read, yes. So thank you very much for watching my video. If everyone have any more question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much again, and see you next videos. Bye bye. Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use TIA Portal version 17 to create the UDT linked with PLC S7-300. If we talk about the UDT, UDT stands for user-defined data type, that we can use only one format, and then we can apply to another function. Then we can just copy and paste to use. Example, we would like to create one motor for control. We had start, stop, or status something. So we just create only one library, user data type, yes. And then we can apply to another motors control by using the library, okay. And in the previous video, we already learned about how to create the UDT for PLC S7-100 1500, and then we use for control the fan, just example by using the faceplate. And for this section we will connect directly to PLC S7-300. Okay, so let's go to our project. We will create the new project and then create faceplate to control from the UDT. Okay, so let's go. Okay, so here is the TIA Portal version 17 that I already installed in my PC. So first we need to create the new project, right? Now I will create new folder. UDT PLC S7-300. Okay, and let's open the TIA Portal version 17. Okay, and then create the new project. I will put the project name PLC S7-300 UDT with faceplate, and then I will browse to find the folder that I already created on desktop, and then click create to create the project. Okay, so here we can go to project view, and then go to create the new device. Yes, because we need to create the hardware configuration of the PLC S7-300, right? So we need to create controllers, and then go to PLC S7 schematic S7-300, and now we use the CPU 314C2PN/DP. So click OK to confirm. And then we will got the CPU 314C2PN/DP, and if we purchase this CPU, we will got analog input and analog output. Yes, totally there are 5 channels of analog input and 2 channels of analog output. Okay, and we also got the 14-bit 24-bit of digital input and 16-bit for digital output. Okay, so it built in the CPU. And we have two part of Profinet and one part of Profibus. Yes. So this is a hardware. So let's check the Profinet port that we will connect the LAN cable to use with the HMI. Yes. Actually, we connect with our PC by LAN port. So we can go to internet address. So 192.168.0.1. Yes. This is the IP address of the CPU. And I will create one HMI to connect with this PLC. So let's go to add new device. Okay. I will choose Schematic Comfort Panel TP700 Comfort version 17. Yes. And then I will connect with the PLC. Yes, PLC underscore 1 here. Okay, and connect with the Ethernet port. And then click finish. Okay, we will got like this. It is the root screen. And here we can rename, yes, to main screen. Or screen 1. Yes. If we rename this one with the screen 1, let's see here, it will change to screen 1. And then let's check the connection, it connect properly or not. Okay, let's see here. It will automatically insert the connection for us. Connect from Ethernet to PLC. And we can also check here, devices and networks. Let's see the Profinet of PLC connect with the Profinet of HMI. Okay, and we can also view the IP address here. So PLC is 192.168.0.1 and HMI is 192.168.0.2, the same as this one. Yes. Okay, so first let's go to create the new UDT. Yes, user defined data type here. I will add one more data type. So double click on add new data type. And then I will rename this one to be example pump data type, pump UDT. Yes. And for pump UDT, I will insert the start command. Yes, so start pump, stop pump, dry pump. Yes, and then I will have pump overload. And then I will have pump fault. Yes, pump overload, pump fault, or pump alarm. Yes. So all this one is Boolean. Yes, there are type. All is Boolean. So we have 5 parameter. We have pump stop, pump start, pump stop, dry pump. It means that the output, or we can write dry. Yes, it is the output to control the relay or contactor when we control from the HMI. Yes, and we have pump overload and pump alarm. Yes. After that, we can go to create the data block. So let's go to program blocks, and then I will add new block. Yeah, double click add new block and go to data block. Yes. So here I can add pump db pump data block and then click OK. And for pump data block, I will add pump 1 and choose the data type pump UDT that we already created. Yes. So I will find pump UDT. Yes, here pump UDT that we already created here. So if we choose the pump UDT, we will got 5 parameters that we assign on the UDT. Yes. So the same as I talked before. If we would like to use the pump 2, pump 3, or pump 100, we can also copy from this one. Yes, I will show. So if we would like to use the pump 2, we just right click, copy, and then right click and paste. Okay, we will got pump 2, and the pump 2 will has 5 items, the same as this data type. Yes. Okay, good. So I will copy to 10 pumps. Okay, I have 10 pumps. Okay, so it's very fast if we use the UDT. Yes. So if we would like to add more pump, we can also copy. Yes. Let's see here. Many items that we can use. Yes. So after that, we can compile. Yes, there is no error and there is no warning. And then we can go to create the function to create the logic of this pump. So let's go to add new block. And then we can go to FC block. Yes. Sorry, FC. And then we can type pump 1 FC. Yes. And then click OK. Okay, so here is the function that we can create the logic for control the pump. Example, I have stop button, start button, output, and then hold the signal. Yes. So here is pump db dot pump 1 dot stop, right? So we will got data type like this. Okay, and this one pump db dot pump 1 dot start pump, and this one is dry, right, output. So pump 1 dot dry, and here we can copy and paste. Okay, and we have fault and alarm overload, right? So if the pump fault, okay, I will if pump start, so I will copy this one and paste. If pump start and pump overload, right? Pump overload. So pump db dot pump 1 dot overload, right? I will set the pump fault or pump alarm. Yes. So I will go to bit operation, and then I will use set coil to set the pump, yeah, db1 dot pump 1 dot alarm. Okay, I will set the alarm, and then if this one alarm, I will let the pump will trip. Okay, yes, so we need to clear the alarm, right? So I can use clear. Okay, to reset the pump. Alarm, yes. So we need one more for reset command, right? So I will put like this first, and then we need to add one more item for UDT here. Yeah, we need to modify the UDT. Okay, I will compile first, and then we need to modify the UDT. To modify the UDT, we can close this first. Yes. And then we can go to pump UDT, and I need one more command for clear alarm. CLR ALM, and it is boolean also. Yes, so we can compile, and if we modify this one, we need go to update on the DB, otherwise it show like this. Okay, so we can right click and then update interface. Okay, so we will got one more command for clear alarm. Yes, all of this clear alarm. Yes, so it add all for item for pump 1 to pump 10. Yes, okay, good. And then we will go to FC1 again, and then put this one to be clear. Yes, so when clear alarm, I will use the pump db dot pump 1 dot clear alarm. Yes, because when pump overload, it will hold the signal here, so we need to clear to reset, and then we can continue to run the pump. Yes, Okay, so that's all for FC1. And then here we can remark or we can comment the network for easy to check the program. So this one start and stop pump. This one when pump overload. And this one clear alarm after reset overload. Yes. And then we can save and compile again. Let's see here. Block pump DB that asset has not been compiled, right? Because we need to compile on the DB first. Otherwise, we cannot compile the FC. Okay. So I go to pump DB here, and then we can compile. Okay, compile finish. After that, I will go to pump1 FC and then compile again. There is no error. Okay, so it's very important. So we can compile on the data block first, and then we can go to compile on the FC. Okay, good. For pump1 is okay. And if we would like to use the pump 2 until pump 10, we can copy here and then paste here, and we just rename this one to pump 2 FC, and then we can open and just change this one to pump 2, right? Change this one to pump 2. Change this one to pump 2. Okay, change all to pump 2. This one pump 2 also. Okay, and then we can close, and here we can close also. Yes, so we can copy and then paste to pump 3. Yes, we can rename this one to pump 3 FC. Change this one to pump 3. Okay, this one to pump 3 also. Because the concept is the same. Yes. Okay. So I use only 3 pump. Yes, so I will copy one more because it's the same concept between pump 1 and pump 10. Yes, so I just example for 4 pumps, so everyone can do by yourself. Yes, then I will copy and paste here, rename to be pump 4 FC. Yes, so this one I will change to pump 4. This one pump 4 also. Oh, this one need to change. Okay, let's change all for hold the signal. Yes, pump 4. Okay, pump 4. Okay, and then save, and we can go to revise for pump 2. Otherwise we forgot to revise this one to pump 2, the whole signal. This one pump 3. Okay, change to pump 3. Save. Pump 4. Okay, already changed, right? Okay, good. Pump 2. Okay, and then we can save, compile the project again. And then don't forget call the FC to the main program. Yeah, to the main OB. So double click the main, and then we can call example pump 1, pump 1 function. Call pump 1 function. So we can drag and drop the FC1 to the network, and don't worry about the FC1, FC2 and FC3 and FC4. If we download, we will work, it will working properly. Yes, and this one for pump 2, we just drag and drop, and this one for pump 3, drag and drop, and this one for pump 4. Okay, after that we can save and then compile again. Okay, there is no error, and then I will connect the LAN cable from PLC to PC to download the logic. Yes, so let's go to check the network adapter. Okay, this one disconnect. Now I will plug the LAN cable to my PC. Okay, here, so connected, the status was connected, and then we can go to the PLC_1. Yes, and then we can compile again. Okay, there is no error, and then we can download the hardware configuration and logic to the PLC. Yes, and then choose the network adapter. Yes, choose the correct network adapter. So I use Intel 82574L gigabit network, and here we can go to select Profinet 1, and then we can start search. Okay, right now it detects one PLC name is PLC_1 here. Yes, and then we can load the program. And then I will stop the PLC when we load the program. I will show the progress. So right now the PLC running. Yes. So I will load. It will stop the PLC. Yes. And finish. To restart the PLC. Okay. And then here we can go online to check the status. Yes. Okay, so the status was connected. Okay. Good. And then we can go to create the HMI to control the FC1 to pump 1, pump 2, pump 3, and pump 4 from the HMI. Yes, I mean that control from the HMI to this logic. Yes. So basically we can go to root screen. Yes. Go here. We will create the faceplate for pump 1, pump 2, pump 3, and pump 4. Yes. Okay. So we can go to root screen, and then this one we can go to add the rectangle. Okay, I will put like this because one page I will put 2 pumps, so totally 2 page. Okay, like this. And then I will insert the start button. We have start button, stop button, and reset button, right? So example, this one start, and go to property to change some configuration or formatting that we would like to change. So this one I will choose solid and then choose blue color. And for the background I will change the color to be this color. Yes. And we have stop, right? So we can copy and then paste here. So this one should be stop. I will adjust a little bit because we have clear, also clear alarm, clear fall. Okay, like this. So we have start, we have stop. So stop I will change to red color. And we have clear lamp, right? Clear fall. So copy and paste. Okay. And then this one should be clear lamp. So CLI ALM. Okay, like this. And then this one I will change the text to be black color. Okay, like this. And then I have pump, right? So let's go to element here. We can insert from the pump from this step, or we can click here. Okay. If we double click, we will got many objects. Yes. From this tab. So let's go to check the some pump from here. We have many styles from here. Okay, this one. I will use this color. Maybe I will change to this color. Yes. This color may be pretty. Okay, pump one. And then we can put the name, yes, of pump. Okay, like this. And I have one rectangle to show the status when pump run or stop. I will change the color to be red color. Okay, good. And then I have label. It is the name, example, pump 1, pump 2, or pump 3, or pump 4. So I will use name. Pump name. And then I will go to use the solid. And then change the text color to be yellow. Okay, like this. Layout, we can uncheck the fit object to content, then we can adjust. And then change to middle, yes. And I will increase the size a little bit. Okay, like this. And then we need to have button for close. Okay, button for close the faceplate. when we would like to close, go to text. Yes, I will change to red, black, and then change the button to be this color. Yes, orange. Okay, like this. And then I will change the color of clear color to be this color. Yeah, to clear the alarm. And then we can save the project, and we need to create the faceplate to apply to pump 1, pump 2, pump 3, and pump 4, right? So we no need to create all for peg like this. So we just create the faceplate, one faceplate, and then we can copy and paste, just change the text, the HMI text, so we can control the pump. Okay. So basically, if we would like to create the faceplate, we can select all these objects and then right click and then create the faceplate. Okay. Example pump faceplate, and this is version 0.1. Okay, so we need to create the property to control the pump. Example start button, stop button, clear button, or show status the pump or pump name, or close the faceplate. So we need to declare the property. Yes. So basically we can declare the property. We can go here, property, and then add new property. Yes. So example push button start, we can rename this one to be start PB. Yeah, example start PB. And the data type is boolean, so we can use boolean. So we can add more property, and then this one stop PB. The data type is boolean also. Yes. And then we have clear. Yes. So CLR PB. Data type is boolean also. And we have rectangle to show the status of the pump run or stop, right? So we will have more property, and this one example status boolean also. And then I have one more for button close the faceplate, right? So I will add one more property for example faceplate visible. The data type is boolean also. Yes. And for the pump name, example pump 1, pump 2, pump 3 or pump 4, we can go to text file and then go to general. Yes, just drop and drop the text to the property item. Yes, so that's all, it linked already. And then for this button, we need to set the event, right? For example, when we start, it will control to the logic. Yes, so we need to go to events, right click events, and then here if I press, so I will set bit if I press, and set bit of property start PB, right? Okay, start PB. And one more, if I release, I will reset bit, start PB also. Okay, and for stop, I will go to events also, go to press, and then I will set bit, go to property, and then go to stop PB. Let's see here, when we assign the events, the faceplate will link to the object property. Yes, so this one should be reset bit, go to property, and then go to stop PB. And for the clear alarm, set CLR PB. When I freeze, it should be clear also. Okay, and for the status, yeah, for the status we can go to animation and go to display, and then choose new apparent, and then change the, choose the status, yeah, because we need to show the status. And for this one, we can add the rank. So when it true, I will change to green. Yes. So we have one more for overload, right? So when overload, we need to add one more property. So overload, and the data is boolean also. Okay, and then when the motor overload, I will let this one, add new animation. We cannot add, right? So I will add one more rectangle, so I can copy and paste. So this one for motor overload. So when overload, I will let this one has blink, right? Red and blink. So I will choose flashing, yes. I will change to another color, yeah, for motor overload here. Or here, yes. So when motor run, it will green. When motor overload, it will show another color, right? So I will keep here when motor overload. Actually, we need to visible when motor run. Okay, when motor overload, I will change to invisible, yes. Okay, I will change to another color. And then I will put here. Okay, like this. And for the hidden, yes. So I will select all. And then go to animation. And then create the new animation. Visibility. Okay, override. Maybe we need to change the option of the overload and run. So this one I will use the faceplate visible and then change to invisible, yes. So we need to hide then if we run the screen, and then we will call from the pump on the root screen, yes. So that's all. We need to release the version and then update to version 2. And we will got like this, yes, because we already update it. And to use the faceplate, actually we can drag and drop from this side, yes, or we can just copy and paste like this. So if we would like to have many faceplate, we just drag and drop from the library. So we will go like this, yes. So it's very easy to create. Okay, I will keep like this. And we need to call, right, the faceplate. Okay, now let go to simulation. It will hidden, right? If we try to simulation, because we already visible from the faceplate property. Yes. Okay, let's simulation and then see the result together. Oh, this one not yet hidden, right? So we need to change a little bit. Let's go to edit the faceplate again. And then let's change all object. Faceplate visible from 0 to 0. Visible, right? Invisible. So that's correct. Okay, let's release the version first. Let's go to the faceplate again. Library, and then we can open this one. Release the version, and then we can test simulation again. It should be hidden, right? Because we already visible it. Okay, not yet. We can go to edit the button. Maybe we have problem with the stator here. So let me check a bit. Visible, okay. Apparent, okay. Overload, that's okay. Status, okay. Okay, let's test this one a little bit. Invisible. Let's test with release version, and then we can go to try to simulation. It will hidden, right? Invisible. We can edit again. Animation, go to invisible. Maybe we need to delete the visibility again. Yes. It should be updated, right? Go to animation. I will delete first. And then we can add new again. Visibility. And then choose the tag from the property. Faceplate visible, right? Rank from 0 to 0 and then invisible. Okay. And then we can release the version. And then we can simulation again. Yes, we can test simulation again. It should be hidden, right? Okay, so we can modify the faceplate little bit. Yes, go to edit faceplate. And then this one I will put like this. And for the close bond, I will use events. When click, I will reset bit. I will reset bit faceplate visible. Yes. And I will select all to hidden the faceplate. Yes. So we can select all and then go to animation. Go to add new visibility. And then for this one we can use visible faceplate and rank from 0 to 0 and invisible. Okay. And then we can release the version. Okay, version number 8. Save and then go to here. So if we would like to hidden the faceplate, we can go to the HMI text and create, for example, pump 1 visible faceplate. Okay, pump 1 visible, and the data is boolean, and I will use the internal text. Yes. And let's go to screen 1 again. And if we would like to hidden, we can go to hidden, go to property, and then we will go to interface here, and then we can use the tag pump 1 visible. Yes. And if we try to run the simulation, it will hidden, right? Okay. So we need one object to call the faceplate when we would like to control, right? So basically we have go to toolbox, and then we can go to pump. Okay, this pump. okay, like this. And then we can call the pump, call the faceplate by using the button. Okay, we can choose like this. And then let's go to property, the button, and then use the transparent. Yes, and then we just put this 1 to 0. We will go like this. And then we have go to events, and then when we click, so I will set bit. The pump visible, pump 1 visible, that we already created the internal tag here. Yes. And then if we would like to put the signal status of pump, we can put here also. And then we can go property, then go to animation, add new, apparent, and then choose the take from the data block, right? Pump 1 we have dry, yes, so we can choose from data block. So when 0, I will use the color red, and when the status 1, it true or on, I will change to green. Yes. And don't forget put this one because we need to call from this button. Yes. So we need to assign the parameter to the option, right? To this faceplate. So first let's go to property and then go to interface. So here the parameter that we need to put for each pump. So we have pump clear, yes, so we can go to choose the HMI tag. So pump 1 clear, yes, and this one pump 1 overload, and this one pump 1 start, this one pump 1 pump 1 status, right? So we can choose dry for status, and this one pump 1 stop, and the last one is pump 1. We can write pump 1, and let's see here it will go to pump 1. Yes, that's okay, so we can test. Simulation, yes. Okay, so right now the faceplate was hidden. So if we would like to open the faceplate, we can click here. Yes, we will got like this. And maybe I will revise this one a little bit for pump run and pump overload. Order by okay, we can put like this, and then we need to release the version, so it become version 9. And then we can save the project and run the simulation again. Okay, and then we can go to main OB1, or we can go to FC1 to see the signal when we click from faceplate. Okay, so if I click here, the faceplate of pump 1 will pop up, and then I can try to start. Yes, let's see, pump running, stop, pump stop, start again. And if we would like to close, we can close here. Yes, we can close and open. Yes, so it working properly. Yes, we can start and stop. And for button clear, we can test also here. Yes, that's good. So we will continue to copy for pump 2, pump 3 and pump 4. Yes, so basically we can drag and drop from the version 9 default here to our screen. We will got the new screen here. Okay, we will got like this, and then here we can also copy. Yeah, I will copy. Basically we can select all from like this, right click and then copy, right click and then paste. Okay, and then we can change. Yes, example this one, we can go to property. Yes, it will got the interface like this also, and then we can put it. So clear bond, we can go to HMI tag and then browse the tag from the DB. Yes, and this one for pump 2, right? So pump 2 clear bond, and this one pump 2 visibility. Yes, so we need to create more for internal tag from here. So I will copy this one and paste. So pump 2 visible, and this one should be pump 3 and pump 4. Because we just put only 4 pump for this video, so we add one more 3, pump 2 visible, pump 3 visible and pump 4 visible, and then come back to our screen. So this one I will choose pump 2 visible from the internal text. Let's go to HMI text and choose the pump 2 visible. And for this one, for overload, I can go to data block, right? Pump 2 overload. And this one, start command. So start pump. This one, dry, right? So we can choose dry. And this one for stop, right? So we can go to stop. So stop pump command. And this one we can write directly to pump 2. Okay, good. And this one also we need to modify. Go to events. When click, I will set bit pump 2 visible. Okay. And we need to change the color. So I will put this one to be animation apparent, and then change this one to be browse from data block and choose dry. Yes, so that's all. And then we can save. And then for the screen number 2, yeah, okay, I will put some text here. Example, TIA Portal version 17, create UDT and faceplate. Connect with PLC S7-300. Okay. And then I will go to property and then go to layout and then uncheck this one because I need to adjust some size. And then go to solid. I will use this color and then change the font to be yellow. And then I will align to be center like this. Okay. Okay, like this. And then we can copy for screen number 2 for pump 3 and pump 4, right? So we can go to copy and then paste here. I will rename to be screen number 2. Open screen number 2. And then this one should be go to interface. Change this one to be pump number 3. Yes. And then this one I will change to pump number 3. Pump number 3 visible. Yes. This one we need to browse. Yes, so we can browse. Pump number 3 clear, right? Clear lamp. And this one we need to browse pump number 3 overload. And this one pump number 3 start. This one pump number 3 status, so I will choose dry. Go to DB, pump number 3 dry. And this one pump number 3 stop, right? Go to DB, pump number 3 stop command. Okay, that's all for pump number 3. And this one I will go to animation and then go to apparent and change this one to be pump number 3 dry. Okay, and for this button I will call the faceplate, right? So we go to events, go to pump number 3 visible. Okay, and for pump number 4 let's go to property and then go to interface, change this one to pump number 4. And then this one I will browse to pump number 4 DB from DB. And then this one clear, right? Clear lamp. And this one pump number 3, pump number 4 visible. This one pump number 4 overload. This one pump number 2, sorry, pump number 4 start button. This one pump number 4 status, so I will use dry. And this one pump number 4 stop command. Yes. Stop command here. And then this one I will go to animation, browse, pump number 4 dry, and for this button I will call pump number 4 visible. Okay, so that's all, but we need to call the page number 2, right? So I will go to page number 2. Okay, go to page number 2. Okay, and then we can go to events. When click, I will activate screen number 2. Okay, and then for this one I will change the color a little bit, maybe this color, and for the text I will put the black. Okay, like this, and then I will adjust. Okay, and we can copy and go to screen number 2. So go to screen number 1, and then I will change the events to be screen number 1. Okay, so we can save, and then we can simulation again. Oh, this one so big, right? So I need to adjust a little bit for size. Maybe 15 is okay. And then we can simulation again. A little bit big, right? Okay, enough. And then we can go to main OP1 or FC1 to simulation again. I will open FC2, FC3, FC4 also. Yes. So first let's go to FC1. So FC1 is running. Yes, PAM was running because we simulation. So we can open FC2. Yes, FC2 here, and then we can online, and we can start from the HMI. Yes, let's see, running, stop, running, and we can go to page number 2 for pump number 3 and pump number 4. Yes, actually we can switch the page like this, right? Because we already configure, and we can also close. Yes, open and close, open and close. So it's very flexible. So I will go to pump number 3, open and online, and then we can start pump number 3. Yes, running, stop, start again. Yes, and let's go to pump number 4. We can online, and then we can start, stop, start. Yes, so good. And right now the PLC not yet connect to some I/O, right? So if we would like to connect to some I/O, we can go here. I will outline first and then go to OB1. So we can connect like this. Example, connect DB of pump 1 to PLC digital output. Yes, and then actually we can go to basic here. We can use the NO contact. So this one I will link from data block. So pumdb dot pump1 dot dry, and then I will turn on the digital output to the PLC. So let's go to device configuration and check hardware configuration here. So the digital output here, we can go to check, go to property, and then we can check the digital output. Start from address Q16 136.0. Here we can remark as pump1 dry or pump1 DR. This one pump2 DR, pump3 DR, and pump4 DR. Okay, and then we can compile, because maybe we need to download again. Yes, input missing TIA here. Yes, so this one I will use pump1 DR. Yes, and for the pump2 we can use like this. So basically NO and coil. Yes, so pump db pump2 dot dr, and then I will control the pump2. Pump2 dr, and this one pump3. So pump3 pump db dot pump3 dot dry, right? And this one pump3 dr. This one we can copy and paste. Pump4. So pumdb dot pump4 dot dry. So this one I will use pump4 dr. Yes, and then let's compile again. Okay, there is no error, right? And then we can download. And then we can online to see the status. Okay, right now all pump was running. Yes, and then I will show the status on the PLC also. Yes, we have 4 output turn on. Okay, let's see the 4 output was turned on. Yes, so if I go to faceplate again, and then I will stop pump number 3. Let's see, output number 3 was turned off. I will stop pump number 4. turn off. I will go to stop pump number 1, turn off. Stop pump number 2, turn off also. Okay, so I will start pump number 1 again, number 2 again, and go to next page, pump number 3, and start pump number 4. Okay, so it worked perfectly. Yes, between our faceplate and PLC hardware. So this is just basic how to create the UDT and faceplate to control the PLC S7-300 by using the TIA Portal. Okay, so thank you very much for watching my video, and I hope everyone can follow me and can do it with our process. If we have any project that related to the motor that has the concept the same, so we can use the UDT and faceplate to apply, because we save the time to create the program. Okay, so in this time I would like to request all of you to like, share and subscribe my channel also, to get more notification and more new videos that I will create step by step. So in this time I would like to say thank you very much again, and see you next videos. Bye bye.